Calculus students, good to be with you here to introduce to you another item in your tool belt called the chain rule. So up until now, we know when it comes to taking derivatives, we know the power rule, and that's for objects such as ax to the n, for example, in a power. We know when functions are expressed as a product, f of x times g of x, for example. We use the product rule. And if they're ever expressed as a quotient, as in f of x over g of x, we use the quotient rule. We've got those in our tool belt. The chain rule looks like this. If we have a function that's expressed as a composition f of g of x, then the derivative goes like this. H prime of x is g prime of x times f prime of g of x. What? So I think of it like this. If a function h of x is expressed as, you've got a outside function, the f of x, and then the g of x is another function that's what I call inside. It's nested in the function. What you do is you take the derivative of the inside, that's g prime of x, and then the derivative of the outside with leaving the inside function alone, g prime of f of x. Now these can be, since they're being multiplied, they can be commuted, of course. That means you could take f prime of g of x and then times g prime of x. But this is how it's usually written, is to take the inside derivative first and then the derivative of the outside with respect to the inside. Here's a couple examples. How about if y equals 3x minus 5, the quantity squared, I'm looking at, and I'm going to label these. Let's see, if we want to find the derivative first, I'm going to say this one, this 3x minus 5, that's what I call the inside. And then the squared is the outside. And I think of it as it's an x squared. Whatever the x is, it's an argument, but it's going to be squared. So that's the outside function. And so when I take the derivative, or y prime, I take the derivative of the inside. So I'm just going to label this right now. I'm going to take derivative of 3x minus 5, and I'll clean that up later. And then I multiply times the outside function. So that's like taking the derivative of x squared. So it's 2 times 3x minus 5 to the 2 minus 1, or 1. Next line, I'm going to take that derivative of 3x minus 5. So my final answer is going to be 3 times 2 times 3x minus 5, or 6 times 3x minus 5. All right, another one. How about y equals radical x plus 5, the quantity squared. Since we're first doing it the first couple times, it'd be nice to label what is outside and what is inside. This is similar to part A. We have the radical x plus 5 is inside, and then the squaring function, that's outside. So in this, taking the derivative of this one, y prime, I take the derivative of the inside, and I'm just going to delay a step here and label it d dx of radical x plus 5, and come back to that in the second step, and then take the derivative of the outside. So it's almost like that is x squared, that's 2 times the original inside function, radical x plus 5 to the 2 minus 1 power. Clean up that second step. Oh, that's the derivative of square root of x. That's going to be, using power rule, 1/2 x to to the negative 1/2 times 2 times radical x plus 5. And that eventually becomes, wow, let's see, that's going to be 1 over 2 radical x times 2 times radical x plus 5. And that becomes, those cancel, and we have radical x plus 5 over radical x. And if you wanted to simplify that, since we have a common denominator, that is 1 plus 5 over radical x.